Today I will be talking about acid-base titration. The aim of this experiment, acid-base titration, is to using a substance which we already know the concentration and volume of to figure out the concentration of another substance which we do not know the concentration of, obviously. So to do that, the first step is to rinse all your experiment equipment. You would have a pipette and to measure exactly a certain volume of yours and solution that you know the volume and that you know the concentration of, not the volume. And normally it would have a volume mark. Most pipette have a volume mark of 25 milliliter. So you would measure 25 milliliter of a substance that of a solution that you know the concentration of, and pour that into a burette. In the burette, for the burette, its volume mark ranges from 0 from the top to something such as 50 milliliter at the bottom. The burette has a type, say this, at the bottom. If you turn the type on, it will start dripping solutions into the conical flask. If you turn it off, it would stop dripping. In the conical flask, you have your unknown solution, which you would know the volume to figure out the concentration. So you would add acid-base indicator to the conical flask, so that you would know when they stop reacting, when the two substances react fully, both the one on top and the one at the bottom. After adding acid-base indicator, you could start your experiment. So you would turn the type on and having them those two reacting with each other. At the point where the acid-base indicator changes color, you would know that they have finished the reaction. And at that point, you could stop the tape and record the volume of your standard solution, which is a solution that you know the concentration and volume of that solution, how much of that is used to react with how much volume of that solution in your conical flask. So now you have the volume of your solution in burette. Let's just note that as VE, V1. And you know the concentration of it, which is C1. And from my last video, you would know how many moles of that substance, that substance in the burette you used. C equals to N over V. So N equals to C times V. And in your conical flask, you have your V2 and C2. And because you would know which substance they are, you would know the chemical formula and the chemical equations of them reacting. And so you would figure out the mole ratio between the two substances, and using the ratio, you would know how many moles of your substance in the conical flask you used. And if after you figure out N2, C2 would equal to N2 divided by V2, you would have your concentration. Now let's do an example. So say if you have H2SO4 sulfuric acid reacting with sodium hydroxide, and then you need to balance the chemical formula. It would be sodium plus 2 water. So let's figure out the mole ratio between the two reactants. H2 sulfuric acid versus sodium hydroxide would be 1, because here it's 1, so the mole ratio would be 1 versus 2. And say if you have say you know the concentration and the volume of sodium sulfuric acid used. That's how much sulfuric acid you used and the concentration of your sulfuric acid, and you will do to figure out how many moles of sulfuric acid you used. You would do N equals C times V equals times 0.1 liter, because it's in milliliter, so you need to convert it to liter, equals 0.5 mole. And how much sodium do you need to react fully with, so how many moles of sodium did you use? Would equal to 2 times NH2SO4 equal to 1 mole. And you also have another condition that you used 500 milliliter of sodium hydroxide. C would be equal to N divided by V equal to 1 mole divided by 0.5 liter equal to 2 mole per liter. So that would be your sodium hydroxide's concentration in this case. That's it for today. Thank you for watching.